Welcome to episode 3 of Trust the Science podcast. We're going to be talking about the history of the polio vaccine as well as some other background information on it.
Yeah, I guess once again for new listeners perhaps, I'm Dr. D.
And I'm Dr. B.
So we've in the past couple episodes led into kind of the conversation of different vaccines, their origin story. And today we're going to focus, as Dr. B said, exclusively kind of on the polio vaccine, mainly because it was one of the first times we had a largely distributed vaccine within the population, not just in the United States, but globally, that was touted as a success, historically speaking, but not without the growing pains that come along with, vaccines, but in general, the implementation of new medical technology. So we're going to start by going over a little bit of background, not just on the vaccine itself, but the disease. I think it's relevant because I don't know about you, but I don't know anyone who's ever had polio personally. That's kind of a problem of a former generation, which is a good thing.
Yeah, almost 100 years ago.
Yeah, and this is more, I think, pertaining to maybe our parents' generation. I don't know how old your parents are, but mine grew up in the era, kind of the last, generation that really had to deal with this. And from what they used to talk about it, they remember getting the vaccine. They remember it being kind of a big deal, that people were being vaccinated for polio. And polio itself was kind of a scary prospect at that time that affected a lot of people in their youth, in their child years, and in some cases, completely altered the trajectory of their lives, as it's a very potentially debilitating disease. We don't really have a good concept of that. I actually asked my students at the local community college here the other day, how many of you know what polio is? And a good portion of them raised their hand, but when I pressed them on it, it didn't seem like they really knew all that much, and I can't really blame them because it's hard to know when that was so long ago. But really, when you think about it, not that long ago in history.
Right, yeah. If you were to ask me before researching this, it would just be polio. Yeah, I've heard of it. I don't even know if I would have known. Was it that Roosevelt had polio?
Yeah, FDR.
And that it caused paralysis. Maybe that it caused paralysis, but other than that, there's not a whole lot. That there's a vaccine that you get when you're young.
Right.
And
that's all we've ever known, really.
Yeah.
I think the only real exposure I had in my mind, other than FDR, is kind of the very well-known example of it, is the opening scene of Forrest Gump, right? Where he's got the leg braces, the run Forrest run, and they fall off. That's kind of my only frame of reference up until really delving into the information about it, and it's pretty interesting. So, without further ado, we'll introduce what was polio. So, up until the implementation of vaccinations in the United States, you'd have on the order of, I've seen different numbers, average of about 20,000, 25,000 cases a year, sometimes higher, sometimes lower. There were local epidemics in years in which outbreaks were much higher. Globally, we're looking probably in the hundreds of thousands, if not maybe closer to 1 million cases a year. It's hard to say, though, because a lot of data doesn't really exist for that.
The important distinction with polio too is that it doesn't just affect older people, but children can get it too, which causes a lot more panic and fear in people.
Absolutely, yeah. I think whenever you have a young population that's already fairly vulnerable, and especially think of that era and all the other things that were already potential killers, add this to the mix, and it's not just that it could kill you, but if not kill you, debilitate you, basically make you crippled. I don't like using that word, but you can't move. Your life has changed, and so in that era too, that was a big deal. But yeah, so average about 25,000 cases or so per year in the United States. And it didn't have the highest mortality, but we're still talking about maybe 3,000 to 5,000 deaths per year, which is a substantial number when you think about, mortalities of children in the modern era. Save, having our COVID pandemic recently, that would be kind of an alarming number. But it's all relative, I suppose. In any case, because of this issue, in the early 30s, as I found out, groups of different scientists began working on vaccination strategies. This actually was information that I didn't know about till fairly recently, because I think when you learn about this story, generally speaking, people skip right ahead to the 50s, where we're talking about Salk and Sabin and Kaprowski, which we will very soon talk about. But yeah, it's interesting. It actually, there were precursors to that all the way back in the 30s. And so there's a couple researchers of note, one named Maurice Brody and the other John Colmer. They were the first to develop polio vaccines, and this happened in the early 30s. So Colmer, actually both of them for that matter, was really the first to get going on this, and they had some crude or rudimentary ways of propagating polio virus, right? You'll see this trend kind of repeat itself. Well, in order to make a vaccine, you have to have active virus. Yeah. How do you get active virus? Well, you have to infect something. And I think a lot of people might forget how that works. Something has to kind of sacrifice or suffer in order to make a vaccine, at least in this era. And the way that Colmer and Brody actually went about this is they would infect monkeys. They would sacrifice these monkeys, grind up their spinal cords.
Is it spinal cords?
Yeah, in this case it's spinal cords. In other cases you'll hear it, the brain, the kidney.
Yeah.
It varies depending on who the researcher was and their strategies. But in this case, spinal cord, which doesn't seem to be the most easy tissue to go after, but I think they're looking for.
I suppose that's where, if the virus affects
the nervous system,
and that causes the paralysis, maybe there's a higher concentration in it.
Perhaps. I think that might have been along the lines of their thinking, but in any case, basically they would grind it up, extract those cells, treat them with, in Colmer's case, retinolic acid, which is basically castor oil, which, yeah, okay, it's probably a denaturant at high concentrations, but not like a crazy denaturant that, it's kind of sketchy, if you ask me. So they kind of make fun of him historically. They're like, this wasn't the most thought out or probably best strategy, but treat it with the castor oil kind of solution, pass it through a mesh, and refrigerate for 14 days. That was the entire protocol. And kind of crude and rudimentary.
And that would inactivate it?
That was, yeah. He was creating what he called an attenuated vaccine. Inactivating a virus. And so I think an important thing to note here too, this is one of the first times, not that vaccines hadn't been implemented in the past. This was actually inspired by vaccines developed for things like rabies, which was much more common back then, and yellow fever, another pretty devastating disease that was kind of not eradicated, but definitely dampened by vaccine implementation. This was the beginning, though, of kind of the era where they're actually testing the implementation of medical, technology before disseminating it, to a large amount of people. But it's still surprising, comparative to what we go through nowadays, and you and I are probably more aware of this because of our line of work.
Yeah.
and all the regulations and testing you have to do before a product can actually be put to market or tested, in clinical trials for even.
There's like no regulation behind it.
No,
It's kind of wild, wild west.
Basically, this guy was like, all right, I tested on 42 monkeys, and then himself.
Oh, he infected himself?
He
shot himself.
He used the vaccine on himself. Yeah.
That's how you know he's a good scientist.
Well, and that was like...
That's how he believed. That's how you know he believed in his shit.
That was pretty common in that era. Is like, well, I'm not going to ask anyone else to do this. I'm going to do it on myself, and I'm either going to die, or it's going to work.
Right.
And so he literally vaccinated himself and his children for good measure.
Hopefully after he vaccinated himself.
Yeah, I don't know. I'm like, that's kind of a bold strategy, man. You really went for it. How do you explain that one to your wife when, you're like, hey, I'm just using our children as a experiment?
Yeah. Well, shows his confidence, at least, in it, or his craziness.
Yeah. Again, bold strategy. And he's not the only one, but still. They were fine. Nothing happened. So he's like, all right, let's try it again. And there's like 23 other candidates, their children, that he vaccinated and no ill effects. So he was like, all right, seems safe. That was the regulation right there. That was it. And I was kind of like, that's it's a little alarming, but
yeah, come a long ways.
We have in many regards. So they distributed it to 12,000 other people. This is in the United States and I think some parts of Canada. And for the most part, there wasn't any ill effects there at first. But it was kind of disputed whether it was fully effective. So there was definitely kind of questions whether it was actually effective at preventing polio.
Oh, okay.
So that was the main issue there. As it transpired over the course of a couple years, they actually were able to record a dozen or more cases of what they call paralytic polio brought on by vaccination. So it's called vaccination-induced paralytic polio. And this is a thing that happens even in the modern polio vaccine, actually. To give you a perspective on the modern version, for every million polio cases, you would get about 5,000 paralytic polio cases.
So if you give the polio vaccine to 1 million people, 5,000 of them?
No. If a million people got polio normally without the vaccine, 5,000 people, or 0.5%, would come down with this paralytic polio.
Okay.
So it's actually not that prevalent, but, in terms of percentages, but, tell that to the person who gets the paralytic polio, right?
Well, how does that compare with the vaccine then?
So the current vaccine that's employed, you don't get polio, but...
So it's 100% effective?
They say 3 in a million could come down with paralytic polio.
Oh, okay.
So, it's astronomically
it's a lot lower.
And just as a fun side fact there, I read about this, and unlike previous polio vaccines that did cause it directly, the paralytic polio, apparently the mechanism by which these 3 cases in a million come about, they aren't actually from the person who was given the vaccine. No, what that happens is they start to produce essentially polio within their bodies, and they shed virus, and they can actually give it to someone around them that may not be vaccinated.
Oh, really?
Yeah, so it's kind of, you're not the person who gets the polio, but someone around you.
Give it.
Yeah, it's kind of a weird mechanism. But back then, in the time of Colmer, it was the person actually getting the vaccine, because there's a couple different hypotheses, but it could be that the vaccine, the virus in the vaccine, was not fully killed, right?
Okay.
So anyhow, after 12,000 doses and the data came back, there was a dozen or more paralytic polio cases. There was at least 6 deaths, which, again, 6 doesn't sound like a lot, but, people became hesitant.
Yeah, I wonder if that's less, if it's less deaths than had they would have gotten it on their own.
I mean,
that's like the justification.
Statistically, it probably, I don't know, I could do the math. What's 6 divided by 12,000? I don't have a calculator on me, but I think the mortality rate was what they said, about average of 3,000 deaths a year with 25,000 cases.
0.05%.
Yeah, so I mean, I'd assume that the mortality rate is still lower with the vaccine.
Yeah.
But nonetheless, I think anytime you see this every day, even currently, if someone gets a treatment, it kills people, you're going to get some hesitancy, right? Obviously, the goal is to never accidentally kill someone but as we've discussed before, there's never a non-risk. There's never zero risk when it comes to medicine or research. That's just kind of an unfortunate truth of the scenario.
Yeah, it doesn't work 100. Most of the stuff doesn't work 100% of the time.
Right. And so even though this was only 6 deaths, or I think they said at least, so there could have been more, they just couldn't maybe directly attribute it. This started to give some hesitancy. This was the first kind of, I wouldn't call it anti-vax movement, but vaccine hesitancy, and perhaps rightfully so. And that ultimately kind of killed the program, and it wouldn't really be reevaluated for at least another decade, because this was in the 30s. At the same time as this Colmer was Brody, and as I mentioned, that he was doing very similar things, grinding up spinal cords, and he would treat them with germicides to try to inactivate the virus, ultimately settling on formaldehyde being the best, which formaldehyde's pretty good at destroying a lot of biological things, so not terribly surprised. But he actually took a little bit more of a practical approach in implementation and testing. He did test upon himself first, similarly. Started with 12 other children, none of ill effect. And then he actually went through kind of like pretty much the first widespread, almost clinical trial. Like he had a placebo group, he had a non-vaccinated group and a vaccinated group of several thousand in each category, and actually used that data to kind of determine efficacy as well as safety. Overall, though, unfortunately, kind of the same issues arose as with Colmer, where people weren't convinced that it was that effective. In rare cases, but in some cases, people were still getting polio. So, taken together, those two guys were a little bit ahead of their time, but weren't failures, but they weren't fully successful. They did, however, kind of set the framework for people to pick up on their work later. Unfortunately, I think both of these characters didn't really live long enough to see, the true successes that came later with it. But that was kind of cool. I hadn't heard about those two people.
They were the first pioneers of it.
Kind of the pioneers there. But anyway, so as mentioned, took a little bit of time, but it was still a big problem. Throughout the 30s, 40s, and into the 50s, polio was still infecting thousands of children and people in the United States a year. There were actually epidemics that occurred throughout the late 40s, in which case over 58,000 cases in 1 year. I think it was 1948. That's quite a bit of people. Anywhere between 1,500 to 3,500 deaths. So people were living, I wouldn't say in constant fear, but it was something that you had to worry about.
Yeah.
And then so in the 50s is where you get this kind of revolution. You get a couple different characters that come into play. The first being a guy named Hillary Kaprowski. I don't know if you've read much on him.
Mm-hmm. No, just Jonas Salk and Albert Sabin.
Yeah, I find that was kind of interesting. Is he actually came first, but he kind of gets lost in the story a little bit, and I think largely because his work wasn't really implemented within the United States. It was these other two that got kind of the credit because they were doing this work in the United States. He was doing a lot of this work in Europe and in other places, so he kind of got lost. But he actually was the first to come up with an attenuated virus that he implemented for vaccination. This was in 1950, so actually like about 5 years before Salk was able to kind of do the same. So this was a inactivated killed polio vaccine. It was actually an oral version too, which comes back around when we talk about some of the other later vaccines. But yeah, as I mentioned, he kind of gets overlooked, and still a very influential character. I think in later years he actually goes into various parts of Europe and kind of is seen as a hero because of his vaccine implementation, but a little bit lost in the United States version of the story, which is interesting. So to get to kind of a couple of the main points, and this is where we start to also look at more infamous controversies, is really beginning with the mid-50s, Jonas Salk. Okay, so Salk was a pretty esteemed researcher at that time. He started developing an inactivated killed polio vaccine, and was largely kind of announced as a triumph in 1955. So he started to implement this. This was actually one that was injected, and that's opposed to Kaprowski and later Sabin with the oral polio vaccines. This was one that was injected. I want to say over the course of a couple of years, they actually vaccinated like 500,000 children in the United States. So this was a huge undertaking. 500,000 doesn't sound like a lot, but at that time, that was one of the biggest, essentially, trials of any kind of medical implementation.
Did you read anything about, because I'm reading here kind of like the biography of Jonas Salk, said that he chose not to patent the vaccine?
Yeah.
Which is a pretty big deal.
It's a pretty big deal. He actually, I think, was quoted as, "I didn't patent it, could you patent the sun?"
Yeah.
Basically saying this is kind of like a human right.
The benefit of humanity.
Yeah, and that's the way he saw it, is he didn't want to really gain monetarily from it. He just thought it was so critical to the well-being of people that everyone ought to have it. And kind of a far cry from what we see nowadays. Kind of refreshing to hear someone actually say, like, hey, I'm doing science for the benefit of humanity, and they actually back it up with action, because everyone says, hey, why did you get into science? Why are you doing science? Well, I want to cure this, or I want to fix or solve this. But
I'm going to make millions of dollars.
I'm going to patent this stuff so I can make millions of dollars. And while I get that, I have a couple pending patents that will probably never make me a dime. That is kind of part of the business, right? Science has been, made into a business. It always kind of has been in some ways.
Yeah.
But now more than ever. But this guy, he kind of went against that grain. It's pretty respectable. Unfortunately, while his vaccine did prove to be fairly effective, and there's a couple numbers here that I think I put that were really good examples of this. I want to say there was an epidemic in the mid-50s with like 60,000 cases. 60,000 cases of polio, right? And within 2 years of his implementation of the vaccine, that was down to 5,600. So that is a pretty stark, loss of cases, which is powerful. They said by 1961, which is roughly 5 or 6 years after widespread use of the vaccine, the number of cases had been dropped to under a couple hundred. So when you look at cases of polio and like the timeline of it, it basically goes from thousands to almost virtually nothing in 5 years. So that does speak to the effectiveness.
Yeah.
And that is, I think, should be regarded as a success. I mean, to this day, we're by and large a polio-free world. I don't know the exact numbers, but I don't think there's been cases of polio in the United States for quite some time due to vaccinations. I know that globally there are still cases. I think the last data point I saw was from 2018. There was like 38 cases globally. But much of that is in rural areas where vaccinations aren't maybe as accessible. A lot of it, I think, was happening in like the Middle East and Pakistan and places like that. But in any case, so Salk, kind of the first big name, he was regarded as a hero. And this was something widely celebrated, at least at first. I mean, there was like some articles I read where people described the moment or the moments in time where this was starting to be distributed, and people were celebrating it on the level of the end of World War II, like ringing church bells, and like people were just blown away that they were living through this time where you could get rid of something as problematic as polio. I think, unfortunately, and you and I have talked about this, what kind of turns into a little bit of a tragedy is that this is undercut or undermined by what's known as the Cutter incident.
The Cutter incident?
Yeah. And are you familiar with the Cutter incident?
I think I remember you talking about it, but not super familiar with it.
Yeah. So what's interesting about the Cutter incident is I do think that is kind of relevant to the current time period and some of the issues we still face. It really comes down to production quality and being able to create a product repeatedly without having something go wrong, without having contaminants. And I think the very common angle that people, pun intended, take jabs at vaccines is what are in them, are there contaminants that can cause harm?
Yeah. This is one of the things with almost all emerging technologies at the time is, if you come out with a new cell phone or app, if it crashes and burns or has technical difficulties, it really doesn't affect things other than annoyance. Right. But if you have flaws in a drug or something you inject into the body, it has potentially life-altering effects, and that's one of the things where there needs to be much more regulation.
The threshold is a little bit higher.
Right, you can kill somebody rather than your app just shuts down.
Yeah, exactly. Well, in this case, I think the kind of the tragedy isn't so much that the vaccine itself was flawed.
Well, we should talk about what the Cutter incident is.
Yeah, exactly. So basically what had happened is the Cutter incident amounted to 260 cases of polio and 11 deaths within children. They had been given the Salk vaccine.
So the background was that Cutter Laboratories?
Yeah, they were one of the manufacturers that were contracted to produce the vaccine, but there was essentially a failing in their process of inactivating the virus.
Right, so the vaccines that they were giving contained live infectious polio virus.
Precisely. And so basically you went from trying to prevent polio to actively giving it to them. And there was projections of, I saw, several hundred thousands of children could have been given potentially contaminated versions of this. If you think about that, though, the fact that only 260 cases and 11 deaths were recorded as a consequence of that is kind of astounding.
Yeah.
But nonetheless, that's a problem, right? And so this was something that caught headlines. At 1 second there, people are very excited and thankful for the polio vaccine being brought out, and then all of a sudden you get a large pullback. Vaccine hesitancy once again, because you're hearing about these cases and 11 deaths and paralytic polio induced by the vaccine.
Yeah.
And to be fair, I think that's warranted, right? But so there's a little bit of a stain on the Salk vaccine reputation, and it really had nothing to do with Salk himself or whether his vaccine was truly safe and effective. It was kind of poor production quality.
Yeah.
Not maintaining, the processes required. And that really falls on Cutter Laboratories themselves, but you kind of get pulled into it. The names all get kind of jumbled together. So it's a little bit of a stain on the history. Some say that was kind of that stain that Salk never really recovered from, or at least the vaccine that he developed never really recovered from. So that's kind of an interesting side note in history where things do happen in medical production. That was a big, issue we'll talk about later that people were worried about with even COVID vaccines, or even before COVID, it was, as we've kind of alluded to, talk in the 90s and into the 2000s about vaccines for MMR that might have contaminants that cause autism, or not even contaminants, but actual ingredients. And so, this is just kind of a very good example of if people aren't doing their diligence, things can go wrong. But this also opened a door for Sabin, who was kind of our other developer of the polio vaccine at that time. So you had Jonas Salk with the Salk vaccine. They call it the IPV, the injectable polio vaccine. And then later, Albert Sabin, who was working on it about the same time, but it just took a little bit longer. He actually was one that became famous for his oral polio vaccine, which was
the OPV.
Yeah, exactly. And that was distributed in 1961. By that time,
the one that might have caused AIDS.
Yeah, we'll get to that. That's the big question mark there. Not just AIDS, but there's actually another one that we'll talk about too, is the contamination of, it's called SV40. You ever heard that?
Mm-mm.
We'll talk about that a little bit as well. But yeah, so big difference here is that it's taken orally. It's kind of activated in the gut, which is interesting. Like the vaccine, obviously you're ingesting it through your gut because you're drinking it. So it has a different kind of mechanism of activation, but it was ultimately determined to be a little bit easier to to distribute because, well, all you had to do is hand someone kind of a dose of it. They would drink it.
Is it more stable too? You didn't have to, because I know like a lot of some certain vaccines have to be stored at negative temperatures or cold temperatures.
Yeah, I'm not actually sure about that specifically, but they are more concerned like, okay, if you have the IPV version, you have to have sterile needles.
Oh, okay, yeah.
To do the injection, and so you have a lot more kind of needs to be able to do that. You have to have someone who's trained to provide the injection. That and, well, people don't like getting shots generally, so try convincing 500,000 kids to get shots. I mean, not that it's really their choice, but it's just a little more pleasant of an experience probably to take something orally than to get a shot. Overall, it is touted as a success. However, there, like Salk, were some complications. People still could get polio induced by the vaccine, which in certain cases could lead to paralytic polio. This was in rare circumstances, but the numbers say that you are far better off taking your chances with the vaccine, and overall that's kind of true for most vaccines. You're probably better off taking your chances, although it can't completely negate the potential causes. One of the interesting things that is looked at now is, as you alluded to, this, they call it the OPV, Oral Polio Vaccine-AIDS theory, which I didn't really know about.
Yeah, I never heard of it either.
I hadn't heard about it really until my dad brought it up in passing, because he likes history. He likes looking at YouTube videos and stuff like that. And we were talking about it, and I kind of wrote it off as like, oh, that's just another one of these crazy conspiracy theories, which perhaps it is. But only recently, when we started talking about it, did I actually go further into it. And
is this where you got another book on, or is that a different book?
No, yeah, there's a couple competing hypotheses here. The first one is that it was around this time where people started looking into kind of backtracking. Where did HIV come from? HIV was not really a big deal globally or in the United States till the 80s. There's a lot of controversy or debate about when and where it originated, and even came into existence within the United States, but even broader.
So what is the name of this? Is it even is it? I don't want to say conspiracy theory, but theory. It's the OPV derived AIDS hypothesis or something.
More or less, yeah.
Okay.
There is a specific name for it, but I can't recall it off the top of my head. But it's basically, there was a conspiracy or at least a theory, and this wasn't just like Joe Blows. There was actual scientists that were backing this. At one point,
OPV AIDS hypothesis.
Correct. Because, well, AIDS seemed to kind of come out of nowhere. That's how it felt.
Well, it came out of the same place where they were testing this OPV, and there was a lot of similarities into it.
Yeah, I believe that was in like the Republic of Congo. Yeah. And so this kind of goes back into how was the polio vaccines made. As we discussed with earlier folks like Brody and Colmer, you have to have some species that's being infected. Well, monkeys were kind of the species. Different species of monkeys were used. I know there was
specifically the vervant.
Yeah, there was several different kinds. Rhesus monkeys, I know at one point. Later, chimpanzees. you wanted kind of a vector that was similar enough that it could be infected, similar enough to humans that, it is logical that whatever happens to them is probably similar to what happens to us biologically speaking. Yeah. And an unfortunate consequence is many monkeys and chimps and various species of monkeys were infected, sacrificed. And as you said, kind of the common practice was to take out their organs, grind them up, and use those cells to propagate virus. And I think it was usually kidney.
Yeah, kidney. Or at least I think that's the OPV.
Yeah. And, well, the thought is that HIV was actually a descendant of what's known as SIV, which is simian immunodeficiency virus. And that itself is a widely established theory.
Yeah, the origins of HIV are complex and likely involve multiple cross-species transmission of the SIV, the simian immunovirus, from non-human primates to primates. Genetic analysis of HIV and SIV have shown that different strains have different primate origins, suggesting multiple transmissions.
Exactly. So, basically, though, the OPV AIDS theory is like, okay, at this time, we were creating polio vaccines by grinding up, organs of potentially infected primates, and then taking those, essentially the polio that came from those animals and injecting it into people. Would it not be possible then to inadvertently give people SIV, which later becomes adapted, if you will, to infect people and then spread, ultimately resulting in the AIDS. They call it epidemic, but it was a pandemic if you really think about it. It was global. And so that's kind of the gist. And there's a couple esteemed scientists that went along with this theory, or at least wanted to investigate it further. It was highly controversial. By the time it really became a mainstream thought, a lot of the people involved in those initial, developments of the OPV vaccine were either long gone, aka dead, or weren't going to talk about it.
Right.
They didn't want to do anything that could stain their reputations, put themselves in risk of being culpable in this, because AIDS epidemic killed millions of people, changed the course of human history, really, and definitely medical history, and that's a whole nother tale. But one of the people that made this kind of theory take hold is a guy named Edward Hooper, who wrote a book. I actually have it sitting beside me. I'll show you how big this book is. Have I read it all? No.
Damn.
Yeah,
how many pages? Was it like 900, 1200?
The last page is 1118. So 1118 pages long. Granted, a lot of that is at the end. It's like footnotes and citations. Which
is good, which you need to have.
Yeah.
Like
so
the citations part.
Edward Hooper is actually a journalist who became interested in this and kind of...
The book's called The River?
The River, yes.
The Journey to the Source of HIV and AIDS.
Exactly. He was one of the people who kind of broke this story and was a huge proponent of, this is a theory. If it's not true, prove it.
Yeah.
And he challenged a lot of scientists. He actually was kind of blacklisted or blackballed, if you will, from the scientific community. They already looked at him as an outsider because he's a journalist, not a scientist. But he had very close ties to prominent scientists, which is why he went through this. He wasn't the original person to come up with this. He just found it and kind of was so convinced that there could be a story here that he went along.
What was his name again?
Edward Hooper. And I believe he's still alive. There's actually a documentary where they discuss this called The Origin of AIDS. It's a little outdated. I want to say it's from the late 90s or early 2000s, but it was still very interesting. Nonetheless, they ultimately kind of brought it into the mainstream. The mainstream scientists actually even tried to set up debates to discuss this. And it all comes back to that idea that we were inadvertently injecting people with contaminated virus from the vaccine. This has been largely refuted by mainstream science, and there's actually another book that I more recently read that's much shorter. I want to say it's like 150 pages. And actually I have that one over here. I'll pull it out. This one is called The Chimp in the River, which I think is a little bit of a dig at Hooper's The River. And it's called How AIDS Emerged from an African Forest. And so this is I don't know if I'm pronouncing his last name correctly, but it's David Cumin. Quammen. But it's a much shorter read. Like I said, it's only 150 pages. But he basically goes through and kind of destroys the OPV AIDS hypothesis. And the main kind of point that he tries to make is that various people have gone back and done testing of samples of both the vaccine from that era as much as they can, and looked for SIV in it. And to my knowledge, they weren't able to find that.
Weren't they only testing like 12 samples because
there's not that many existing samples?
Yeah, it was tested decades later, and they didn't really. And it just takes a couple, like one mutation, which we know that the OPV did have mutations because it went from inactivated to activated and caused polio and certain things. So there are mutations. And there's also, they didn't know about SIV during that time. So when you're actually taking this virus, how do you know that you're not taking another virus with it?
In fact, that's why they looked also back at this I think it's SV40, which we'll get to in a minute. But yeah, so like they didn't know. Yeah. And so it's plausible that if this was a viable theory, that you could go back, find samples.
It's not a BS theory.
But they weren't really able to do that. There was a couple times where they thought they got hit, but it was controversial, and they later found out that it wasn't kind of the smoking gun that they were looking for. They couldn't rely on the data. And yeah, because this really wasn't thought about for 30 plus years after the fact, it makes sense that you're not going to have too many chances at that.
Right. In these trials in the Congo where they did give the OPV vaccinations in infants and children, there was like 250,000.
Yeah.
So it just takes 1
in theory
to 5. That's the theory. It's just 1 to 5 of these things. The chances that happens is very low, but also the chance that 2 of them happens and 1 of them is going to be tested is also very low. So it's one of those weird tests where it's really hard to prove or disprove. Well, it's really hard to disprove because you don't have all. Yeah. You don't have all the vials that were given. You didn't test every single vial that was given.
You were administering them. You weren't storing them.
Right.
In any case, so that was kind of where that came from. The other point they make in that the chimp in the river is that there's an alternative hypothesis that is widely believed to be the culprit, and it's called like the wounded hunter hypothesis of transmission of AIDS. Basically saying that, okay, people in Africa, especially that part of Africa, Congo area, they come into contact with animals. They either hunt them, some cases eat them, maybe even are attacked by them. At some point, it's plausible that either through a wound or ingestion, a person was infected with SIV, harbored that for their lives, transmitted it either through contact with other people, by blood, or even sexually transmitted. And only after several generations and iterations of SIV did it later become HIV. And this is actually supported because they've gone back and found cases of people who had these kind of weird deaths in the 50s and later that couldn't be attributed to anything specific at that time. Granted, their medical prowess at that time maybe wasn't as
especially
high
in Africa.
But they would find, samples, blood samples that have been stored in refrigerators, or at least in one case, they had like biopsy samples stored in paraffin that had just been sitting on a shelf for decades. And they would go back and they determined that these people had been infected with a virus that was similar to HIV, but was definitely a older version, a descendant of what is currently, infecting people. And I think what people often forget is that HIV is pretty complex. There's actually various serotypes of HIV with different genetic markers. And so with the technology we have at our disposal today, people can actually backtrack which HIV strains based on mutations emerged from other strains further back in time. And so just like we have kind of a family tree, we can look at HIV, or any virus for that matter, and kind of determine when were these breaks in or forks in the tree, so to speak, where we have common ancestries of different versions of the virus. We see this a lot right now with COVID, right? It's a very rapidly mutating virus, so we have all these like different versions every couple months. There was gamma and all these different versions of it.
They're on to
few weeks.
now.
Yeah, we're on to numbers because we kind of gave up. I don't even know what it is anymore. But the point is, they were using software and algorithms to kind of track these mutations over time, and they gave a timeline of when they thought maybe the initial infection could have occurred. And it was far earlier than the 50s. So the whole point was that people are trying to say that this was the way that HIV was transferred, was through these polio, vaccinations. But in fact, there's a lot of data that suggests that it was much, much earlier than that people had been infected with SIV decades before those were even implemented. Interestingly, too, they allude to the fact that this wasn't probably a single person infected with SIV. It actually, there was enough differentiation within the different samples that they found of HIV and SIV through human sampling that they projected there could be anywhere between 5 and a dozen different times in the last 200 years in which people were independently infected. And that's because they have specific mutations that were of uncommon ancestry. So that means they were introduced into the population at different times. And so this is what has been largely used to kind of debunk the whole theory. However, as you mentioned, it's hard to completely debunk because
you can't really ever fully debunk it because you didn't test all those things, which is unreasonable to test at the time.
Yeah, it's kind of hindsight's 2020, right? But even if it didn't happen in the 50s, and people are saying it could have happened at there's several different dates. One's in the 30s, One's in like 1908. One's in 1915. It's hard to even calculate exact precision when it happened, right?
Yeah.
But instead of like looking at the 50s, who's to say it wasn't from Palmer and Brody? You know, they were grinding up monkey spinal cords, but
yeah.
I still think it's fairly unlikely.
Yeah, I think it's just the timelines match up more towards the OPV.
Yeah,
with the 50s.
That was kind of the
like
big
confirmed death was in 1959 of AIDS.
Right.
Which was a few years after like the mass trials in the Congo.
Exactly.
And the first death was in the Congo too.
Sure. It was location and geography. It was timeline.
Yeah.
Now
similarities in the viruses.
What I'll say is that, is it the reason that HIV is in the population? The sole reason? No.
Yeah.
I think that I'm kind of on board based on the other information, the genetic testing and the kind of looking back at the mutations. Probably unlikely. But could it have contributed? I think that's a big question mark. Sure. I think it's possible. Is it clear that there was some sketchiness going on with the manufacturing of these OPV vaccines at the time? 100%. I don't think that anyone would look at that and go, oh yeah, that seems to be like the best way of doing it. No, it's very clear that there was issues going on there. So there are still lessons to be learned, whether this can be refuted, debunked, or not. It's still kind of an interesting side note in the whole polio vaccine, story.
Okay. But that brings us into SV40.
Yeah, so I don't know how much you know about SV40. I know
Nothing.
A little bit, but not a lot. So SV40 is short for simian
virus 40.
Vacuolating virus 40. I don't know if I said that correctly, but it is found both in monkeys and in humans. Actually, we can be infected with it. It's thought to, in humans, there's a hypothesis that SV40 might cause cancer. This is a really controversial area of research. This was actually another one that was brought to my attention from my very curious father, so thank you, Dad. But one of the controversies is that there's thought that there was historical contamination of batches of the polio vaccine that contained SV40 in the 50s and 60s. And actually, there is evidence that is true. That they were able to go back and determine there were instances where SV40 was present.
In the vaccine.
And the reason why people were really concerned about this basically comes because there was studies on other animals with SV40. And I want to get this right, but I'm not certain. I think they did tests on like rodents. Maybe it might have been hamsters. They were given, this infecting agent, this SV40, and to develop tumors. And so obviously you're like, okay, these rodents were developing cancer. Is it possible that humans could have been getting cancer if they were infected as well? Now, as far as I know, while it's speculated that there could be a relationship there, it's not very compelling.
Yeah. Inconsistent and inconclusive.
Yeah. There isn't like conclusive data to say that is the case. They've even looked at kind of cancer rates in places where the vaccine was widely distributed and could have contained SV40, and statistically speaking, there was no rise in the amount or prevalence of various cancers. So they don't think, because there was kind of this consideration that, okay, in the last 30, 40 years, cancer rates have gone up substantially, right? What is the cause of that? We've kind of briefly talked. Is it like the food? Is it contamination of environment?
Yeah.
It's
all of it at this point.
It's all of it, right? There's an article every day that's like, if you do this, you'll have cancer. And I'm like, oh God, I'm fucked.
Yeah.
I mean, if you're a chemist, which we were, you're already kind of on the short path. But so people are constantly looking. They want something to blame, right?
Well, yeah, they just want actionable results that they can do something to avoid. And it's like if you give them this ineffable thing to be scared of, you kind of just paralyzed by it. You don't know what to do. Right.
And so people are looking this as kind of like, maybe this is the smoking gun. Maybe this is why we all have cancer.
Yeah, or just one of the smoking guns.
Yeah, but in fact, I don't think they were able to prove that at all. That isn't to say that people can't be infected by it and weren't infected by it, but they don't think it was actually the cause. Now, do we take it one step further down that conspiratorial pathway and be like, well, are they really going to admit to something like that?
Yeah, but it has been removed from the vaccine, so
right. So now it's not. It's kind of a non-factor, but it was kind of like should you trust, quote unquote, science and the people behind the science, because clearly there's a precedent for them failing at making sure that these products that are being, quote unquote, scientifically vetted and developed,
safe and effective. They're not as safe and effective as they might say.
Or pure, you know. And so I think that this all leads to kind of, as I've mentioned before, a little bit distrust in the medical establishment, in scientific process, and I think we've gotten a lot better, probably because of these instances, right?
Yeah.
Because there is now a little bit of, well, don't be like these people. You know, we were trying to not repeat the mistakes of the past. But I think that distrust is natural. I think at a certain level it's healthy. But I think it can be taken to an extent where it is maybe not healthy. And so there is precedent. And that's kind of why we're doing this, right? Is I don't think it's illogical to not have questions or concerns.
Yeah, you should always question, or you should always verify things. You might, trust, but also verify that.
I think that's going to be the t-shirt slogan that we come up with, right? Trust, but verify the science, right? And this happens.
These newer ones, you can't really verify it either.
It's hard, yeah.
There's not long-term studies. And so it's like you do have to just trust it, and you can't verify it until decades later.
The people who took that vaccine at that time, they trusted it.
Yeah.
Because that was their option. And who knows? Maybe in 5, 10, 20 years, someone else is doing a podcast just like we're doing now, going, man, those idiots all took this vaccine, or these scientists were morons because they didn't think of this.
Yeah.
It's very plausible. I mean, that's part of the kind of ongoing scientific process, is we try to learn from mistakes, and unfortunately there are consequences to those mistakes, but you don't know it immediately,
right?
Most of the time. So it's kind of a fun exercise to go back and look at these things. I don't know that, other than kind of making people aware, that we can say all that much about them. I'm still reading about it, just gotta find them fascinating, but not necessarily as compelling as they might have been decades ago.
I think it just shows that we need much better verification procedures and protocols, and yeah.
I mean, again, overall, I think it's still safe to say that polio vaccines, they were successful at reducing polio.
Net positive, unless they caused AIDS, then it's
unless they caused it. That's a big asterisk there, but let's side on the assuming they probably didn't or weren't the lone factor contributing to AIDS, but Yeah.
Even with all the for sure deaths and virus or polio that they did cause, the stuff that, or the polio that they helped prevent is still been a way higher net positive.
And I think if you look at it this way, aside from the contaminants that really don't have anything to do with the vaccine itself or kind of the mechanism by which that vaccine works, it was just kind of an accident that they were there in the first place. It was an oversight. It's not that the scientific idea behind the vaccine was flawed and dangerous. It was the implementation of the procedures and the process of manufacturing and distributing it that were flawed. Yeah. So it's a failure of the people, not of the technology necessarily, not of the science.
Other than the ones that are attenuated and then become live again.
Okay, well,
which is a small percentage.
That's a small percentage. And they've learned from that.
Yeah.
They've learned from that. And they've gotten better at reducing that.
But they're not perfect.
They're not perfect.
There's still cases.
Sure. You could be that
polio.
3 in a million.
Right.
But, I mean...
which is good to know.
Stats are on your side, but it's not a zero factor.
You should be an informed person when it comes to this.
Right. And I think that again, as we'll talk about later, does apply now, right? Because for what it's worth, and this isn't the end of this series. We're going to talk about vaccines for a little while. But this is a problem that we're seeing actually at much more alarming rates in the current time pertaining to COVID vaccines than these other ones. And I think that's the interesting side note is that vaccine hesitancy and anti-vax, ideologies have existed for a while. And really, statistically speaking, it was kind of almost laughable for a little while because, like, in retrospect, obviously it's serious when someone dies or becomes disabled from a vaccine. But in retrospect, you're looking at the stats and you're like, okay, yeah, that sucks to be in that percentage that are affected, but overall, seems kind of clear cut. But we're at a threshold now where we have to really consider, is it effective enough to warrant taking the risk?
Yeah, well, that's the similar with drugs and stuff too, with all the fines and the deaths that have been directly caused by a lot of these deaths, whether it's the opioid epidemic, the other multi-billion-dollar fines, which I suppose we could probably do multiple podcasts on. And
I mean, episodes and whole podcasts. I mean, people are already doing it, but it's a part of kind of medical science. It has inherent risks.
I think that at least where I'm at, I think lifestyle change is much better than any drug or most drugs. I mean, the truth is, if you have a healthy body,
people lived for thousands upon thousands of years. I mean, maybe not that long, but they were able to survive, and in some cases, survive for quite some time. They didn't have the drugs at their disposal. I've always been kind of fascinated with Western medicine versus traditional,
the voodoo,
traditional medicine, or like Eastern medicine. There's like all these kind of weird taboo, treatments that people you see online. They're like, you have neuropathy, you should take this tree bark, or extra.
Well, it just goes to show like the placebo effect of where if you think that you're taking a medicine, it can actually help you even if you're taking nothing.
There's definitely legitimate science that's verified that.
Right. And so that's now why they have to give placebo control, where they give them the active drug as well as placebo, because you need to know how much the placebo effect affects.
But there are also instances where people are like taking these, non-traditional Western medicines,
snake oil,
and sometimes it doesn't go well, but there are times anecdotally where it does. And if that happens enough time, people start to take notice, but they don't have a defined mechanism. Right.
They don't have the actual statistics.
They work, but they don't know how. And in some cases that is true in Western medicine as well. We give people drugs and they're like, yeah, it reduces your pain, but we don't know what receptor it's hitting. I mean, like, what aspirin was like that for a really long time.
Yeah, we know it works. We don't know how it works.
Yeah. So it's like we put a lot more, I think, faith in like scientific understanding. Like, oh, well, this is on a shelf and I'm legally allowed to buy it and take it at will. So someone must have vetted, like, and knows exactly how it works.
Yeah.
That's a whole nother thing. We're kind of getting away from the main points, but it does, I think, have a little bit of relevance. But
okay. Yeah. Let's wrap this bad boy up.
Yeah. In any case, hopefully you now know a little bit more about the origins of the polio vaccine, knowing that it is largely successful and implemented today, but it wasn't without controversy and some incidences that caused people to
specific failures
and second guessing of the system at play there. But I've really enjoyed looking at this, and I hope you guys enjoy us discussing it. Do you have anything that you want to end on?
No, just thanks for listening, and I don't know what we're doing for our next episode, but
I think we're going to delve into the vaccination causation correlation potential of autism.
Oh, autism, right.
Yeah, and I think that's a really interesting kind of next step here, because we're kind of going chronologically.
Yeah, but we shouldn't just focus on vaccines. We should focus on some other things that might... I was listening to a podcast today where a doctor was talking about they took the gut biome of a kid with autism and gave it to a rat or a mouse, and after a couple of days or weeks, the mouse displayed autism-like symptoms as well.
Yeah.
So there could be a lot that goes into it, and so we'll go into
the, I guess, hypothesis behind the causation correlation, the story behind it. I think it's an important story to tell because it further illustrates kind of why people maybe distrust science. In this case, there was thoughts of exaggeration and hyperbolic strategies to make their work sound more compelling, if not full-on plagiarism. But we'll definitely not discuss it from a simple one-sided viewpoint. So yeah, there's a lot of research ongoing into the mechanisms there, but it really came to the public eye, I think, around the same time, which is why it's kind of still out there as a potential.
Well, there's just a huge uptick in autism, and people want to know why.
Yeah, just like cancer, just like all these other things. And I think we are curious as a species. We want to know why these things are happening, right? To try to mitigate it and avoid it ultimately. But yeah, so that's kind of what's coming up next. So thank you for listening. I'm Dr. D.
And I'm Dr. B.
And this was episode 3 of Trust the Science. We'll talk to you next time.